Hi guys, today we're going to do a little review on some of the things we've talked about concerning decimals in class. So I have here some base 10 blocks and you should be familiar with all of these base 10 blocks because they're ones that we've talked about in class. Now, most often when we're talking about place value, we're talking about the ones place, which would be this little tiny block here. We have the tens place, which is equal to 10 of these ones. We have the hundreds place, which is equal to 10 of these tens and 100 of these ones. And then this big cube here is the thousands place, which is equal to 10 of these hundreds, 100 of these tens, and 1,000 of these ones. Now, today we're going to talk a little bit about decimals and how these can also work for decimal place value. So we're going to start here with this big cube. Instead of calling this big cube 1,000, we're going to refer to this cube right now as one whole cube. When I say one, I mean just one whole cube. So instead of looking at as all of those small pieces making up a really big thing, we're just going to look at all these small pieces making up one thing, because technically this is one cube. Now, if this is equal to 1, we're going to talk a little bit about what are each of these pieces equal to. Well, if we know that this is 1, we know that all of these are smaller than 1. So we know that these aren't whole numbers. So the first thing I'm going to do is talk about this piece right here. Now, before we said that this piece was 100. So we're thinking, how many of these pieces would it take to make this piece? Well, really quickly, we can figure that out by just 10 of these would be equal to one of these, and we can put them right beside each other and notice that they're the same. So because it takes 10 of these to make one of these, this piece here is called 1/10. So 1/10 would mean that it's 1 out of the 10 it would take to make this. If we had 10 of these 10th pieces, that would be the same as one whole. Okay, so we know that. Let me set this to the side. So now, let's talk a little bit about this piece and what this piece would be equal to. We know from before when we talked about that it would take 10 of these pieces to make a 10th. So it's a little harder to figure out how many of these pieces it would take to make one of these wholes. It would actually take 100 of these pieces in order to make one of these. Now, I can prove to you that it would take 10 to make one of these tenths just by snapping. And you can see here now that 10 of these pieces are equal to one of these pieces. Since it takes 10 of these to make one of these, and it takes 10 of these to make one of these, it's going to take 100 of these to make one of these. So we call one of these smaller pieces, we call it a hundredth. So far we have a whole, we have a tenth, and we have a hundredth. Now, the last piece that we have is this one little cube here. Before we called it a 1, but keep in mind, if this is one whole, this is much smaller than that. So we're trying to think, how many of these does it take in order to make one of these large cubes? Well, one place I start out by doing that is I snap my fingers. 10 of these ones is equal to one of these tens. Now, because it takes 10 of those ones to make 1/10, it takes 10 of these pieces to make one of these pieces, and it takes 10 of these to make one of these. We're thinking 10 times 10 times 10 means that it would take 1,000 of these little cubes to make one of these large ones. So we call these pieces 1,000ths. So we have one whole, we have a tenth, we have a hundredth, and we have a thousandth. Now we're going to talk a little bit more about what these would look like if we wrote them as numbers next. All right, so we just looked at those 4 different pieces, and we talked about what each of those pieces were worth if that one large cube was worth one whole. So we're going to start out with the large cube from before, and we're going to look at how we could write each of these as numbers. Now, this first one is just 1. So remember, the ones place is our first place. So a 1 would just look like this. So this is a whole number. Keep in mind, anything to the left side of a decimal is considered a whole number. Now, we said that if this was equal to one whole, we said that this next piece was equal to 1/10. The reason for that is because it took 10 of these in order to make one whole. So if we wanted to write that as a decimal, it would look like this. We would have a 0 in our ones place. We would have a decimal point, and we would put a 1 here. So this number, it says 1/10. Now, if that is a tenth, this next piece we had, we called it a hundredth. It took 10 of these hundredths in order to make a tenth, and it took 10 of it takes 10 tenths to make a hundredth, or a whole, so it takes 100 of these in order to make one whole. So the way we write 100th is, again, we put a 0 in the ones place, we put a 0 in the tenths place, and we put a 1 in the hundredths place, and that shows 100th. The last piece we have is this little piece, this little cube. Remember, it took 10 of these pieces to make a hundredth. It takes 10 of these hundredths to make a tenth, and it takes 10 of these tenths to make a whole. So it's going to take 1,000 of these in order to make a whole. So we're going to call that little piece 1,000th, which looks like this, which means it takes 1,000 of those to make a whole. Now, when we're looking at these pieces, a lot of times we can't figure out which one is the largest. A lot of people think thousandth sounds the largest because 1,000 is a big number. Now, when we're working with decimals, though, it's kind of backwards. 1,000th is actually the smallest of these pieces we're talking about right here because it takes so many of them. It's splitting the whole up into little tiny pieces. Whereas a tenth, for instance, it's splitting the whole up into pretty big pieces. So a tenth is much larger than a hundredth, and a tenth is also much larger than 1,000th. So keep in mind the different sizes of those pieces and think about that as you're working with decimals.